Alan, shall we start the program? Alan, Abhirami madam,
Yes, sir.
shall we start the program?
Yeah, sir. We can start.
Oh, okay.
Good afternoon to one and all present here. We extend a warm and cordial welcome to the afternoon session. I'm going to walk you through the entire session. Once again, I welcome our guests, director, HOD, faculties, and our fellow participants. Now, I request my dear student Sugita to give a review of morning session.
Hello everyone. Before I start, I would like to express my gratitude and pleasure for being a part of this 3-day virtual national workshop on research methodology and data analysis using MX Excel. Let me share my experience about yesterday's session. Dr. Sasiskumar, Assistant Professor, Manonvayan Sundarnath University, Tirunelveli, walked us through the morning session on fundamentals and research and statistics. Sharing of knowledge is where one can learn more and more. We all really had a great learning experience in the means of both theoretical and practical approach. Followed by Dr. Aarti, Assistant Professor, Christ University, Bangalore, walked us through the afternoon session on descriptive analysis using MX Excel. She gave us a clear-cut explanation on how to use MX Excel with all its basic and advanced operations. She also guided us to clear all our doubts during the session. On the whole, the day is a power-packed all day with a wonderful knowledge-sharing experience. Now I will request my dear classmate Aishwarya to give a brief introduction about today's session.
Trend analysis is a strategy used in making future predictions based on historical data. It allows to compare data points over a given period of time and identity uptrends, downtrends, and stagnation. If a trend is stable and steady over a period of time, it indicates consistency and invokes more certainty than a trend that is drastically changing positions. However, inconsistent trends might be more attractive to some investors to analyze certain external factors contributing to the radical trend changes. High risk usually involves chances of high rewards. Investors and business managers use this information to make data driven decisions and improve strategies. Hypothesis testing is concerned with statistical testing of postulates, usually concerning parameters in an empirical way, that is, from data. It is an important subject and step in all spheres of data analysis. The session aims at providing the basis of hypothesis testing with emphasis on some commonly encountered hypothesis tests in statistical data analysis.
I would like to call upon our respected HOD to deliver his welcome address.
Thank you. Is it audible? Is it
Yes, sir.
audible?
Yes,
Oh,
sir. Yes.
so very good afternoon to all. Today we are in the last session. So we are happy now. I hope that many participants now they have basic knowledge and research methodology and the data analysis. Particularly, we use MS Excel effectively and also efficiently. So I know the many people eagerly participated and also raised the questions. So today the session will begin with a topic of Sorry. Today, the session will begin with the topic of trend analysis and hypothesis testing. As an organizer, I know we are not able to complete all the things in 3 days. So we have to spend more time with the MS Excel. How efficiently analyze our data and also how we present our data and also result as well as. Now we started the primary step of data analysis using MS Excel. So when you practice more about with MS Excel, definitely I can tell you will be a master in MS Excel. So continuous practice is more important to get benefit of this workshop. So dear participants, now you have wonderful resource person, Dr. V. Muthupandian, Assistant Professor, Sikkim University, Gangtok. So we are very happy to welcome our today chief guest and resource person. Behalf of our college and Department of Business Administration, I heartily welcome our today resource person. Welcome you, sir.
Thank you, sir. Thank you. I do, sir. I do.
Karpasamy sir. Karpasamy sir. Sir, your voice is not audible. You are
Mic mute பண்ணி பேசுறீங்க.
Now is it audible?
audible.
Right. And I also welcome all other participants. I hope that you make this session as fruitful session, right? So thank you for everyone to engage yourself with this program. Thank you so much.
Hello. It gives me immense pleasure to introduce our resources persons of today's session, Dr. M. Muthupandian, Assistant Professor, Sikkim University. Learning is a way where we can develop our own knowledge, but sharing our knowledge with others is a way where our knowledge becomes a possession. Only few peoples in the universe know the essence of way where our knowledge sharing, and one among them is with us today as our resources person. We are really grateful and thankful to you for inaugurating and engaging the day one section, and also for showing your support by being connected with us. Without any further delay, I would request you to carry forward the session with your valuable words. Over to you, sir.
Thank you, ma'am. Thank you so much. Thanks for the organizer and other guys who are all involving directly or indirectly to this program. My voice is clear, audible. Anyone can unmute and confirm.
Yes, sir. Your voice is audible.
Okay, no disturbance.
No, sir, no disturbance from your side.
Fine. Thank you so much. So we will begin our session in a couple of minutes. So today what we are going to talk about is the two part while discussing with our coordinator or a program organizer, Professor Dr. R. Karupasamy sir, related to the in relation to the discussion of what we can discuss on today. So today what we plan is hypothesis testing especially, and also sir wants to include a little bit about the trend analysis. It's entirely a different dimension. The trend analysis is it's a different set of data, and then the hypothesis testing is a different set of data sets. You know very well, the hypothesis testing, generally we have to use it in the cross-sectional data majorly, and then the trend analysis in a financial time series data. Okay, so we are discussing both on today's session. So I'm going to share the screen. Kindly confirm whether my screen is visible to you all. My screen is visible to you all?
Yes, sir.
Fine. So today what we are going to discuss about is hypothesis testing in MS Excel. Okay, this is usual, my affiliation details and other things. The contact information is also there. So today what we are going to start about it. So today what we are going to start about it, 5 concepts we are going to discuss. Very first one is a small recap about the statistics, definition, functions and types. And the second one is the level of measurement. I hope this will be completed by earlier resource person also. But for a name shake, it is required here. Again, I want to recall all the concepts, because all the tools and techniques, whatever the tools and techniques you are going to use, all are based on the level of measurement. All are based on the level of measurement. What type of measurement, what level of measurement you are using for your data, according to all the tools and techniques, descriptive statistics or inferential statistics techniques, whatever the tools, all are depends on the level of measurement only. Touch upon slightly on level of measurement, then we will move into the appropriate descriptive statistics, because based on the level of measurement, the different type of data, different type of variables is required a different type of descriptive statistics. All places we cannot use the mean. You may study about the central tendency, you may study the different types of central tendencies, it is mean, median, mode, you may study it. Where we have to use the mean, where we use the mode, where we use the median. So these are all depends upon the level of measurement, what type of variable we are having, or what type of measurement of variable we are having. Based on that only it will be there. So that's why we have to talk about that appropriate descriptive statistics, appropriate inferential statistics, and then we may go and do a little bit hands-on training on MS Excel, how to do hypothesis testing and how to do a trend analysis and other things. Okay, so this is our session. So what we are going to discuss today. So we start with a very broader term of statistics. Before we are enter into the statistics, you should understand about what is meant by a population and sample. Population is nothing but it's a collection of all possible individual or all possible unit of measurement. Our measurement of interest is called generally population. The sample is a representative element or representative unit of measurement. Representative unit of measurement. So whenever we are talk about that, if you are describing about the population, if you are describing about the population, it called a parameter. If you are describing about the sample, it called statistics. Here you should understand about that. What does mean by description? What does mean by description? So description means you have to explain how it is. For example, many of them you may saw my photo. So based on my photo, you may try to describe me how I am. Okay, if somebody asking you, you have to start describing me about how I am. Okay, so I'm wearing specs, I'm using tika, I'm using that what we call sandan in the forehead. So this way you are start describing how much height I am, how fat I am. So this way you are going to describing me. The same way you are going to describe the variables. You are going to describe the variable, each and every variable. Otherwise, you are going to describe the data set. That is we call statistics. That is we call statistics. Similarly, if you are going to describe the entire population, if you are going to describe the entire population, it termed that parameter. It termed that parameter. Okay. So this is the sample and parameter. You should understand that when you are describing a population, it's called a parameter. When you are describing a sample, it's called statistics. So what is the definition of statistics? Statistics may define as a science of collection, presenting, analyzing, and interpreting the numerical data from the logical analysis. So you have to do data collection, presentation, analysis, and interpretation. So these are all the four major stages or four major component. This all you have to done in a scientific way. That is, we call a logical order. If you are doing certain things, if you are collecting data, means it behind some scientific reason why you are choosing. If you know that different types of data collection is there for your respective study, what type of data collection is scientifically appropriate, you are a man behind the study, you should know how which type of data collection will help you to justify it. So each and every stage you have to pass on a help of scientific way. Okay, scientific manner you have to design your things. So in the statistics we have to do this four components. And why we want to do the statistics, what function it does. So when we talk about the statistics, these are all the functions. Very first function is condentation. We already discussed about that. Condentation means a mass data, few convert our mass data converted into our few observation. Very best example is, past classes you may studied about frequency table. In the past classes you may studied about the conversion of frequency table. Otherwise you may heard about the histogram. Okay, creation of histogram. So these are all what is nothing but it's called condentation. Nothing but it's called a condentation. Means a mass data or a huge data we're going to convert into few observation. Few observation. It's nothing but it's a grouping, or it will be compressed. Okay, that is we call just condentation. That is the main function of statistics. So if I will throw in front of you, 500 students mark, 10th standard 500 students mark. Otherwise, if you take in your class 60 students are there, all the 60 students mark I will show in front of you. What you can observe, what you can understand. You can't understand anything. Instead of I'm showing the 60 students mark in front of you, what I can do is I can categorize it. How I can categorize it? Who are all secure less than 40 marks? Who are all secure 40 to 60 marks? Who are all secure 60 to 80 marks? Who are all secure above 80 marks? In that manner, I can condentate it and I can report it, means it will give more information about you. That is does by a statistics main function. And then comparison. Then after you have to classify like this, you have to compare how the composition of my class. All peoples are above average, below average, like that. This type of comparison you can do it. Okay, that is we called a comparison. Okay, then estimation based on the past data, based on the information available in front of you. For example, based on the sample information, you are going to estimate the population parameter. You are going to estimate the population value. That is we call estimation. And forecasting. Forecasting is nothing but based on the past data, we are going to predict the future value. Based on the past data, past historical data, we are going to predict the future value. And finally, we are doing a hypothesis testing, whether whatever the tentative conclusion we are having, or a tentative statement we are having, or sometime we may call some myth is there, we want to test it. Some myth is there, we want to test it. What is the myth? It may be a general statement. Instead of simple statement, what we are going to do, we are going to do the testing the statement with the help of a statistical tool. Testing a statement, we have to choose we have to apply the statistical tool to test the statement. It's called test of hypothesis. called a test of hypothesis. For example, certain motorbike company, they come up with advertisement of my bike will give a 60 kilometer per liter. So this is a statement we have to test before they come to the common advertisement or a public advertisement like this. Before they have to test it and prove it, themselves they should understand it's right statement or not. Unless otherwise they should not come to the public. If they will come to the public, then the people will easily question that, they will questioning that particular statement. Okay, so these are all we generally termed as a test of hypothesis. So these are all we are going to talk about it in the statistics. And when we talk about the types of statistics, generally the statistics will be classified into two categories. One is a descriptive statistics, another one is the inferential statistics. Under the descriptive statistics, we are going to another name of the descriptive statistics is called as EDA, exploratory data analysis. EDA stands for exploratory data analysis. Okay, so the descriptive statistics, what is the role of the descriptive statistics? The role of the descriptive statistics is they are going to describe the characteristics of the sampling data. Descriptive statistics, what they are going to do? Descriptive statistics is going to explain the characteristics. Going to explain the characteristics of the sampling data. And when we talk after studying a descriptive statistics of the variable, then we can decide what we are going to do. We are going to test the hypothesis. Otherwise, we are going to calculate the estimation. Based on the sample, we are going to estimate the population value or not. For example, a very simple logic for a sampling. If you want to understand the simple logic of the sample is, if you are suffer from certain viruses, what they are doing, they are taking some blood drops from your body. You will take some blood from your body and they tested in that particular virus is available in the particular your blood drop, means they may come to the conclusion that you are infected, your entire body is infected by that particular virus. Okay, this is the example of sampling. So instead of they will suck out your entire blood and test, and they will come to the conclusion that yes, you are affected by that particular virus, means what we can do. Once they will suck up the blood, means again they cannot put it in your body. So in that situation, what they will do, they will take certain sample from your body. Blood sample they will take. That's why it's called a blood sample. They take certain blood sample. In the blood sample is consisting of the particular virus. Then they may conclude that, means what they do, based on the sample result, they are going to generalize that particular result to the population. What is the population? In your entire body, blood is called a population. Based on the sample, they are going to conclude about the population. Based on the sample, they are going to conclude about the population. That's why when I start my statistics, my statistical teacher said that our mother is the best statistician. Simply what they will do, if they want to boil a rice, not in a cooker, okay, so if in a pot they are going to boil a rice, they will take certain sample, and she concluded that the entire pot of rice is boiled or not. Okay, what she do is she takes certain sample from the pot and check whether that sampling rice is boiled or not. If that is boiled, automatically she concluded that the entire pot of rice is boiled. So this is we called a generalization. For this type of generalization, we require the statistics. Okay. So when we talk about that, inferential statistics is dealing with this too, hypothesis testing as well as the estimation. When we talk about the hypothesis testing, there is a different types of hypothesis testings are there. Whereas in our study, we are going in general PhD and then MPhil studies, they may use this two types of hypothesis testing. One is we call test of means, another one is we call test of relationship or association. Test of mean and test of association. Test of relationship or association. Okay, another type of hypothesis testing is called test of means. Okay, so these are all the things we are going to discuss. When we talk about the exploratory data analysis, this you may studied about it. In the exploratory data analysis or a descriptive statistics, we are going to talk about the four important components. Important components are measures of central tendency, measure of dispersion, identify the shape of the distribution, identify the flatness of the distribution. This will be called as mean, median, mode will call the measure of central tendency. Measure of dispersion may be a range, standard deviation, interquartile deviation, interquartile range, and shape of the distribution is called a skewness, and then the flatness of the curve will be called as kurtosis. So this is nothing but central tendency means what is the middle value. What is meant by dispersion? Dispersion means how much it deviated from the mean value. Each and every observation, how much deviated from the mean value. And skewness is talk about the how it is. It is a symmetrical curve or it is skewed somewhere. It is skewed somewhere. Left hand side is skewed or right hand side is skewed. Like that we can talk about it. And then finally we are going to talk about the kurtosis. It talk about the height of the height. Okay, how much tall I am, how much fat I am. My fatness will be talk about the skewness. My height will be talk about the kurtosis. How I am different from other people. Okay, that you may know about my standard deviation. How much I stand. I'm a one particular. You're describing me the same way you are describing the data set. The same way you are going to describing the data set. That is we call descriptive statistics. And when we talk about the estimation, in the estimation, two types of estimations are there. One is a point estimation, another one is the interval estimation. Point estimation, we are going to estimate only one value. Interval estimation, we are going to estimate the two value. One is the upper value, another one is a lower value. Upper value and then lower value. Within this range, our value will be come. That's why it is called, that's why we called as, this is we called as interval estimate. Interval estimate, confidence interval estimate. So how to calculate this interval estimate? Point estimate. Point estimate is nothing but the mean or like that. So the point estimate plus or minus confidential interval. Confidential interval. How to calculate the confidential interval? Confidential interval will be calculated by confidential level multiple by margin of error. Confidential level multiple by margin of error. Confidential level multiple by margin of error. So this is the formula we use to calculate the confidential interval. This is the value you talk about the confidential interval. Okay, fine. So the next part is we are going to talk about the hypothesis. So what is meant by hypothesis? Hypothesis is a statement or an assumption or a claim about the value of the parameter. So that is why I am saying that it is a statement. Generally, you, for your understanding, it is a verifiable statement. We want to verify that certain statement. There is a lot of myths are there. For example, generally you may heard about that females are, girl students are performing better in the schools. Girl students are performing better in the schools. So this type of one myth is there. Okay, we want to test whether that statement is correct or not. Correct or not. And somebody they may say that my medicine is having a more efficacy to control the particular disease. How they will come up with this type of conclusion? By using the hypothesis testing. So when we talk about the hypothesis testing, there are two statements are there. One is we call a null hypothesis. Another one is we call the alternative hypothesis. One is we call the null hypothesis. Another one is we call the alternative hypothesis. The null hypothesis. Another one is the alternative hypothesis. So null hypothesis, always we have a word called equal. Okay. Otherwise, there is no significant difference. Okay. Equal to symbol is a mathematical symbol. The mathematical symbol, I will write it in the text. How I can write? There is no significant difference. Okay. Equal to is a symbol, mathematical symbol. The mathematical symbol, how can I write? There is no significant difference. Means that is equal. Okay. So this is the way we have to set. So you may have a doubt how I can set the null hypothesis. Whenever you want to set the null hypothesis, that statement should not furtherly questionable. If I am saying certain statement, the statement should not be furtherly questionable. If this characteristic is there, then only it will be called as null hypothesis. For example, in this workshop, there is a lot of participants are there. We may have a male participant and we may have a female participant. Okay. So what I am saying is, male participants are more active than female participants. I will pass this type of statement. I will pass this type of statement. What happened? What happened? Immediately the female participants are raising a voice. Sir, how you can say like this? Maybe you are a male charming, that's why you are saying like this. You are not liking of females, so you want to degrading the female, that's why you are saying like this. This type of comments will come. So if I will pass certain statement, it will be discussable, it will be furtherly questionable. So this statement should not be a null hypothesis. Okay, then I can change my statement. Female participants are in attending this program compared to the male. Like that, I will pass also. All the male participant also rising their voice. How do you can say like this? What proof do you have like that? What you are favoring to the female? Like that, they will raise the voice. Is it right?
Excuse me, sir.
So in that, yes.
Sir,
Yes,
if you don't
Manjulana?
mind, can you please repeat this? If you don't mind, can you please repeat this particular slide, because I had a connection problem. Just this slide, please.
Same slide. I'm there in the same slide.
Yeah, but
You want a
I could
previous
not.
slide?
No, this slide itself. But can you just repeat this
is,
particular?
What do you want? You want to repeat my narration, or you want to see my slide? What do you want?
No, slide is visible, sir. I just narration,
Okay.
because I could not follow this particular one because of network problem.
Okay, fine. So I will repeat. Please, I will conclude it, and one more time I will tell that. Okay. Fine. Okay. So when we talk about the null hypothesis, it should be furtherly, it should not be questionable. Whenever whatever the statement we passed, that should be furtherly, it should not be questionable. That statement will be called a null hypothesis. So the null hypothesis statement always have a equal symbol, equality symbol. Equality means equality symbol. It's an equal symbol in mathematics. But I want to narrate the mathematical symbol into the textual form. How to write the textual form? The textual form I have to write there is no significant difference. There is no significant difference. Okay, that word I have to use. So I am saying that in the class, in the participant group, I am saying females are more attentive, like that. Okay. So in that case, what happened? Male participants are charging me. How do you say like this? How do you say this? What evidence do you have? The same way I am saying males are more active means female participant, they will raise the question. So these statements are not a null statements. These statements are not a null hypothesis. When nobody will raise the question, I'm saying male and female participant both are more active, more attentive. Like that, I will say means nobody will questioning my statement. If I'm saying like this, anybody will rise? Male and female participants are equally attentive in my session. Like that, I will say means anybody will raise the voice, anybody will ask the question, nobody will ask the question. So it is not furtherly questionable statement. That statement will be our null hypothesis statement. That statement will be our null hypothesis statement. When we come to the alternative hypothesis possess inequality symbols. Alternative hypothesis statement should possess inequality symbols. Inequality symbols means there is a 3 inequality symbols are there. What are the 3 inequality symbol? First one is not equal to symbol, second one is greater than symbol, third one is less than symbol. Okay, so these 3 symbols are called as inequality symbols. These 3 symbols are called as inequality symbols. So either any one of the symbol will be used in the alternative hypothesis. If I am using not equal to symbol, if I am using not equal to symbol, my hypothesis will called as non-directional hypothesis. My hypothesis will be called as non-directional hypothesis. That is also called as two-tile test. When we called as a two-tile test, in my alternative statement, I am using not equal to symbol. Not equal to symbol. Only not equal to symbol. Okay, not equal to symbol. Okay, otherwise there is a significant difference. Like that only I am saying. I am not concerned about greater than, male is greater than female, female is greater than male. I don't want to conclude like that. I want to conclude that male and female are not equal. I want to conclude only that much. Means that type of hypothesis testing is called as non-directional hypothesis. Otherwise, it will termed that two-tile hypothesis. When I want to say whether one item is greater than other item or other item, one item is lesser than other item, like that I want to say male is greater than, male salary is greater than the female salary. Female willpower is less than the male willpower. Like that I want to prove means as directional hypothesis. Otherwise, we may term that one-tile hypothesis. Otherwise, it will be termed that one-tile hypothesis. Otherwise, we may term that one-tile hypothesis or one-tile test. Okay. So when you can see this diagram, you may able to understand what is the one-tile test, what is the two-tile test. Okay. What is the directional hypothesis and non-directional hypothesis. So here you want to understand only one thing. The directional hypothesis or non-directional hypothesis depends on your alternative hypothesis. Directional hypothesis and non-directional hypothesis always all depends on your alternative hypothesis. It not depends on your null hypothesis. Okay. So this is the way we can conclude. We can say that what is our null and other things. Okay. Fine. When we are, and many people still they have a confusion about this two concept is called level of significance and level of confidence. Level of significance and level of confidence, it's entirely different. This level of confidence and level of confidential level and level of confidence, these two terms are entirely different. You should understand the term. That's why especially I designed this. So the level of significance or level of confidence, what does mean that? The level of significance or level of the significance level or the level of significance, it is a maximum value of the probability rejecting the null hypothesis. Whenever we want to reject the null hypothesis, whatever the hypothesis main objective is, we want to reject our null hypothesis. What is the probability value that rejecting the null hypothesis? When it is true. In other words, the researcher is willing to take a much certain percentage, usually 5% risk of rejecting the null hypothesis, even the null hypothesis is true. Even the null hypothesis is true. Even the null hypothesis is true. Okay. So for your easy understanding, what we can do is I can give a little thing. I want to discuss about the little concepts with you. So kindly unmute yourself and answer for the query, answer for the questions. Then you may easily understand. Okay. So here from Madurai to Thoothukudi, I want to check whether how long it will take to travel. I want to travel from Madurai to Thoothukudi. So I asked certain people, they may say that 4 hours it will take. By road, it will take 4 hours. By road, it will take 4 hours. Okay, I want to test it. So how I can test it? I can travel by myself. For your easy understanding, I will take 100 times I'm traveled. For your easy understanding, I'm traveled by 100 times. I traveled by 100 times. Otherwise, I interviewed 100 people who are all travel from Madurai to Thoothukudi in a different point of times. Those are two situations. I can travel myself and I can test. Otherwise, what I can do, I can take 100 samples randomly. I choose 100 passengers traveling from Madurai to Thoothukudi by road in a different days and a different timing. So I have to ask them how long it will take. Okay. So after I'm collecting all the data, I will check that 95% means 95 people are saying that. 95 people are saying that it will take 4 hours. It is less than 4 hours. Like that they say. Then what is your conclusion? What is your conclusion?
4 hours.
You decided that it will take only 4 hours. Even though 5 people say that not 4 hours, you will not consider that 5 people. That is we call the error rate. Even though 5 people they say that, we will not give much importance to that particular 5 people, or we will not give importance for that 5%. 5% people maybe sometime because of some unnatural events, it may happen some delay. So that's why we will eliminate that 5% of people. Even though our null hypothesis, what is our null hypothesis? Traveling time is equal to 4 hours. That is our null hypothesis. Alternative is not equal to 4 hours. I am testing. So what happened? 4 people they are rejected. Even though there is a truth, 5 people. Even though I'm not satisfied with that. I'm not taken their decision. There's 5% people I can. There's 5% people I can eliminate it. 5% people I can eliminate it knowingly. That is we call alpha rate, alpha level, error level. Okay, accepting level of significance. Okay, somebody they may say 10 people. If they say like that, also I don't bother about it. Means 10% error they accepted. Okay, now the similar situation. You are checking 100. You are checking 100. You are asking 100 people. Out of the 100 people, 45 people are saying that it's not equal to 4 hours. Then you concluded Madurai to Thoothukudi traveling distance is 4 hours. Out of 100 people you interviewed, or out of 100 people you asked, 45 people says that it is not equal to 4 hours. It's greater than 4 hours. They are saying like that. In that situation, do you concluded that Madurai to Thoothukudi traveling distance is 4 hours?
No, sir.
Why you are not concluding? Why you are not agreeing? Because that you fix 5 people say means we may agree, but here 45 people are saying, so above our error level. So that's why you are not accepted. Okay, this is we call level of significance. Whereas when you come to the confidential level or level of confidence, okay, with how much researcher confidence about the outcome of the hypothesis testing, the probability of rejecting the hypothesis when it is false. This is our level of confidence. For example, there is a two term. One is the level of significance, that is the error rate. Another one is the level of confidence, LOC. Okay. In our case, error rate is 5%. So level of significance is 5%. How much you are confident about your result? 95% you are confident about your result. So your level of confidence is 95%. Your level of confidence is 95%. Very simple. Whenever you want to understand this logic, the level of significance and the level of confidence is always equal to 100. Okay. Level of confidence and level of significance is equal to 100%. Okay. So this is the logic. You should remember that. And here one point you should remember, level of confidence and confidential interval is a different term. It's not a same term. For example, you can see here in this slide, we are talking about the term called confidential interval. Confidential interval. The term confidential interval is different. Confidential level of confidence is different. So that is I want to highlight it here, because many researchers they confused with these two terms. Level of confidence and confidential interval. Okay, both terms they may confused, both terms they may say, they may feel that it's similar, but it's not like that. Both are different. Okay, so I want to highlight it here. And when we talk about the hypothesis testing, this is the important thing about it. You should understand how, when we can reject our null hypothesis, when we can accept our null hypothesis. Okay, so what I will advise you is, there is a two method is there. One is a manual method, another one is a computer based method. When manual method means whenever you are worked out the problem manually, you will get certain things based on that. But right now we are not going to calculate anything manually, so we use a computer method. So that's why what I will suggest is second table you can refer it. P value. P value stands for probability value. P value stands for probability value. So we are going to talk about this probability value only. So the probability value, P value, is a computer based method. So whenever the P value it comes, we have to check the P value with our level of significance, LOS. P value we have to check with the, compare with our level of significance. Okay, so the level of significance we have to compare with the P value. So the level of significance is in a percentage. That's why the P value you have multiple by 100. Then you will convert the P value into a percentage. P value into a percentage. General, by default, our level of significance is 5%. By default, our level of significance is 5%. Whenever we want to check the hypothesis testing, our is 5. Okay, so we have to check the P value. P value is greater than or equal to 5%. P value is greater than or equal to 5%. We reject our null hypothesis. For our case, I'm saying now. For our case, I'm saying 45 people are saying, 40 out of 100 people, 45 people are saying Madurai to Thoothukudi distance is not equal to 4 hours. 45 people are saying, out of 100 people, 45 people are saying Madurai to Thoothukudi distance is not equal to 4 hours. Then what happened? What is my P value? P value is 45. Okay, 45%. What is our general error rate? 5% is our error rate. 5 is greater than or equal to 45. That's why we reject the null hypothesis. We are unable to reject the null hypothesis. Okay. So when we can reject our null hypothesis, our P value is less than our error of rate. For example, if you are asking 100 people, 4 people are saying Madurai and Thoothukudi distance is traveling time is not equal to 4 hours. Only 4 people are saying. Then you may reject the null hypothesis. Because our error rate is less than that. This is the concept. So you could understand. We cannot. There is a two statements is there: null statement, null hypothesis, and alternative hypothesis. When the null hypothesis is rejected, alternative is accepted. When we are null hypothesis is unable to reject or fail to reject, alternative is rejected. Because null hypothesis, we should not use the word called accept the null hypothesis. Instead of you are writing the word accept, you can write fail to reject, unable to reject. You have to write like that. For a null hypothesis, you should not use the word called accept the null hypothesis. Whenever you write a paper, whenever you are writing any research articles, you don't use the word called null hypothesis. You don't use the word accepting the null hypothesis. You have to use the word unable to reject or fail to reject. Okay. So this is the point I want to highlight it again. Okay. So this is the thing, and then we are going to talk about that. Next is level of measurement. So Stevens, 1946, they classified variable into 4 different categories, 4 different measurement. That is we called nominal, ordinal, and another one term called cardinal. The scale data. The scale data will called cardinal. Later that word will be removed, and the cardinal variables are classified furtherly into interval and ratio scale. So for your understanding, you don't bother about much like this. You may think about only three things, because whenever you are using a SPSS software, there is only three classification. Whether your variable is a nominal variable or ordinal variable or scale variable. They will not much difference about the interval and ratio variable. Okay. So in a beginners, you should understand there is a three types of measurements is there: nominal, ordinal, scale. Nominal, ordinal, scale. That much is enough. Now, if I will give certain variable, you may able to tell whether that variable is a nominal variable or ordinal variable or scale variable is enough for identify what type of test we require. We are going to use. Okay. So when we talk about that, these are all the variables and level of measurement. So all the level of measurement, what we can do, what we cannot do, I am given here. These are all for your reference. You can refer it a little later, because I don't have a time to talk. I don't have a time to talk each and everything here. Okay, fine. So next part, what we are going to talk about is what type of appropriate exploratory data analysis or descriptive data analysis we are using based on the measurement, data measurement, based on the data measurement. For example, when my data is a nominal data, when my variable is a nominal variable, I use only the mode. I use mode. For nominal data, you should not calculate median, mean kind of thing. Okay. Nominal data, the central tendency, appropriate central tendency is mode. Measure. Dispersion, not applicable. Flatness, kurtosis and skewness, not applicable. So nominal data, you should calculate only the mode. Otherwise, you calculate the proportion. Proportion means ratio. Total, how much? For example, out of 100 participants, or out of 100 participants here, 40 people, 40 are male, 60 are female. So 60%, 40%. Like that, you calculate the proportion. Otherwise, you calculate the mode. That is the only thing you calculate for a nominal data in the exploratory data analysis. When my data is a scale data or ordinal data, especially ordinal data, you can take like that. When my data is a ordinal data, I can use a median. Central tendency is the median. Measures of dispersion is called interquartile range. How to calculate the interquartile range? M3 minus M1. That is the way you have to calculate the interquartile range. Okay. Again, the shape and other thing is not applicable. When my data is a scale data, then only I can use mean, standard deviation, and then kurtosis, skewness. These are all applicable only for my scale data. If my data is a nominal data, if my data is a ordinal data, you should not use mean, median, mode, standard deviation. These are all you should not calculate. Even you calculate also, you should not report. Whenever you draft your research paper, whenever you prepare your thesis, project kind of thing, depends on the data measurement, variable measurement, you have to use the appropriate tools. Okay. For a nominal data, you should not calculate the standard deviation. You should not calculate the kurtosis, skewness, these type of things you should not calculate. For example, gender is there. You should not calculate. For median, standard deviation, and kurtosis, skewness, for the gender data, you should not calculate. Okay. Similarly, the ordinal data. Ordinal data means your categories are there. What is the category? assistant professor, associate professor, professor. This is there. This is ordinal data, ordered data, ordered data. So this ordered data, you should not calculate. You should not calculate everything. Means you should not calculate the kurtosis skewness for this data. You should not calculate the kurtosis skewness for this data. Understand? So when my data is a scale data, then only I can calculate. For example, if you have a income, income you are collecting as a open-ended question. So here that is also very important, because that's it. Very earlier itself I tell to the sir, it's a very long process. We cannot completed all the things in a given point of time. Okay, so you should understand about open-ended question, closed-ended question. Okay, so we can collect the data by an open-ended question and closed-ended question. So when you are using an open-ended question, generally the data will be a scale data. Okay, for example, there is a two-way to ask the age. There is a two-way to ask the age in your questionnaire. There is a two-way to ask your age in a questionnaire. So how to ask? Very first way, how to ask? State your age, put the dash, or mention your age, dash. In this way you are collecting, means this is we call open-ended question. This is we call open-ended question. If you collect the data by this manner, you will get the exact age of the respondent. That data is called a scale data. When instead of you are collecting an age of the respondent by this, you can ask another way. How you can ask? Choose your age. D 20 to 40, 60, D 60 to 80, E above 80. Like that, you option to the participant, choose the appropriate age group. When you are collecting a data like this data is a ordinal data. This data is a ordinal data. This will not give a scale data. You got the point? So what way we are collecting a data is more and more important. And what is my advice, serious advice to the researcher here is, try to collect the scale data as much as possible. Whatever the data you collected in a scale form, try to collect it in a scale form. Later we can convert our scale data into the ordinal data or nominal data. Data will not lose. Whereas while you are collecting, at the time itself you are collecting a nominal data, means you cannot convert the nominal data into the scale data. It is really impossible. Whereas if you are having a scale data, you may able to convert your scale data into the categorical data. Whereas if you are collecting a categorical data, you cannot convert the categorical data into the scale data. Got the point? So this is much important. So as a researchers, take the serious concern about it. Whenever you are drafting a questionnaire, try to collect as much as possible the scale data. Okay, fine. So these are all the various functions are available to calculate the descriptive statistics in the MS Excel. Okay, so if you want to calculate the mean, you can use this function. If you want to calculate the standard error, you can use this function, like that. And here my data is available on A2 to A11. So my data set is available on A2 to A11. 10 observations are there, A2 from A11. Okay, so based on that condition, you can apply this formula according to you where your data is located. For example, in your case, your data is located in a different area, means you slightly change the address of the cell within the bracket. Slightly change the address of the cell according to your data location. In the Excel sheet. Okay, so these are all the various functions are there. I hope some of the functions you may studied in your yesterday sessions. Is it right? Some of the function you already studied, na? Is it right?
Yes, sir. Yes, sir.
Fine. So some of the functions you already studied, no problem. I'm not going to touch. I'm not going to tell individually how to calculate. Okay, I will show you in a single click how to calculate this all. how to calculate this all in a single click. Okay, I'm going to share you. Okay, fine. So next what we are going to talk about is what type of mean test and other things are there. So before we are going here, before we are coming here, I will already bored much enough of last 1 hour. So what I can do is we will do slightly hands-on training, then we will come back here. We will do slightly hands-on training, then we will come back here. Okay, so we can travel again to my Excel sheet. So this is our Excel sheet. My Excel sheet is visible to you all. I hope this all
Yes, sir.
this is the same Excel sheet you may also receive it. Is it right?
Yes, sir.
So if you want to parallelly practice, you can practice all together with me. Otherwise, you can do it little later also. No issue. Okay, fine. So here, very first sheet is called LSD sheet. That is we called linear regression. Okay, we are going to use a linear regression here. Okay, so the linear regression model, that is we call LSD model, least deviation model. Okay, least standard deviation model we are going to use. So here we are going to use the LSD model. So there is a two approaches are there. So you may know very well. So this is a time series data. I'm going here to calculate the alpha value and beta value. For example, if you want to predict the value, this alpha value and beta value is required. So how to calculate the alpha value and beta value under the two methods I am given here. Why I want to give a two method here? Because certain textbook they are following this method. In certain textbook they are going to use this method. Okay. Very first method, the t value. What is the base difference is? The t value. So you can see here the t value. You can see here in the first method the t value. T value is what? Progressive. 1, 2, 3, 4, 5, 6 like that. It start from 1, it go on. Okay. So this is our x value, because in a time series, t value will be considered as a x value. Okay. T value will be considered as a x value. Okay. So this is the data. So you can apply here, means you will get the value like this. Okay. Alpha value and beta value. So I given a formula here. You want to do it in a manual also, you can do it and you can know that my answer is right. Okay. So you can see the same data is same. Here you can see 2011 70, 2012 80, 2013 96, 2014 100, 2015 95, 2016 104. Values are same, but you can see here my alpha value and beta values are different under this both method. My alpha value and beta value are varying based on the method. The first method is my sigma t is not equal to 0. Here you can see my sigma t is 21. My sigma t is 21. Here you can see my sigma t is 0. When my sigma t is 0, I can use a simple formula to calculate my alpha and beta. When my sigma t is not equal to 0, I have to use little bit complicated formula for calculating the alpha and beta. Okay, this is the logic. Okay, so whatever the method you want to, what you feel which is easy, you can follow it. It's not a matter. But Excel follow the first method. So what you are saying, sir? Yes, Excel follows this method. So I want to show you how it is. Okay. So I just select. If you want to do a trend analysis in Excel, first you have to draw a graph. So what I am doing is I am inserting a line graph. Are you able to see my line graph here? Everyone?
Yes, sir.
Yes, sir. Yes, sir.
This is year. I don't want. That's why I just delete my year. So once I deleted my year, this is my line graph. Okay. In this line graph, what I'm going to do is I'm add the trend line. What does mean by this trend line? Are you able to see my trend line? Everyone here, are you able to see my trend line? Everyone?
Yes, sir.
I just make it into a different color for your understanding. I just make the trend line in a different color. Okay. How to calculate this predicted y value? The predicted y value is nothing but alpha plus beta x. That is the equation I am using. Alpha plus beta x. Okay, alpha plus beta x. That equation I am using to predict my y value. That equation I am using to predict my y value. Okay, so alpha plus beta. So here I am using alpha value is located on D24 and beta value is located on D25 multiplied by D15. So what is my D15? D15 is nothing but my x value. D15 is nothing but it's my x value. That's why I'm using like this. So based on this way, I am predicted the y value for each column. After predicting, based on this value, this trend line is drawn. Trend line is drawn. I need not to calculate. You don't feel it. The values are calculated here. That's why it is coming. It's not so. So even you don't have a predicted value, also the trend line will come by default in Excel. Got to the point? There's a various type of trend lines are there: exponential trending, logarithmic trending, binomial. The same thing I am calculating here. It is right. Are you able to see? Otherwise, I will zoom it.
Yes, sir.
I will zoom it. Are you able to see here the value and this value? So this is our alpha value and the beta value. This is our alpha value and the beta value. This is the way you can use your prediction. This is the trend values. You can calculate the trend value, y value, and r square value also you can calculate. Okay. Got it? How to do it? Now we will go for forecasting. So based on this data, how we can go for forecasting? After a certain period, I want to calculate. For example, here only 2016 is there. I want to calculate for 2018. I want to calculate the 2018. So how to calculate the 2018 value? 2018, what is the x value? 2016 ka x value is 6. So 2018 ka 6 value will become, x value will become 8. So in this equation, you substitute 8 here. In this equation, you substitute 8 here, you will get the 2018 value. But in a Excel, you need not to bother about it. You can calculate by machine itself, it will calculate. I will show you. Machine itself, it will calculate. I will show you. Okay, so you go to the next sheet. So this is our data. Is related to exchange rate data, USD INR exchange rate data for 2019 for 3 months. 2019 for 3 months. So what I'm going to do is, first I will draw a graph, line graph. This is a financial series data. So what I'm going to do is, I'm going to insert a graph. Line graph I'm going to insert. So this is my data. This is my data. For this data I want to add a trend line. Add the trend line. So I get the trend line. So what I'm going to do is, I want to display the r squared, display the regression equation. Okay, this is my regression equation. This is my r squared. This is my r squared. Now I want to predict slightly. Now I want to predict the graph slightly. So how to predict? So the prediction will be available. Forecasting will be available after 2016 version. In Excel, if you are having 2016 version, then only you may able to do the forecast. Unless otherwise the forecast sheet is not available. If you are having above 2016 version, then only the forecasting will be possible. So I can click forecast. So are you able to see my forecast here? Are you able to see my forecast here? The orange line, this is the forecasting period. So you can, this two lines are able to see. One is the upper line, another one is a lower line. Center is the point estimation. Center is the point estimation. Upper line, lower line you calculate means this is we call interval estimation. This is we call interval estimation. This is we call interval estimation. Okay. So you want to forecast how much you want to forecast, what confidential interval you want to use. This is all you can set. This is all you can set. This is all you can set here. This is all you can set here. Okay. If you want, you can see like this. If you want, you can see like this. Okay. Well, yeah. If I will click create, what happened? You will get the new sheet. In the new sheet, you will get the predicted graph. You will get the predicted graph. So you may be able to see the predicted graph. This is the predicted graph. After prediction, as well as what you will get is prediction, as well as what you will get is upper value and lower value you will get. This is the center value, predicted center value. This is the lower value. This is the upper value. This is the lower value and this is the upper value. Okay. So these periods. So what it happen is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Based on the 3 years data, it predicted almost 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. It predicted around 21 data. It predicted 21 data set. Sir, I want only for next 10 days, you can predict. Sir, next 30 days, I want, you can predict like this. So, okay. So this is the way we can do our prediction. This is the way we can do our prediction. 21-day prediction is there for a 3-month data. 3-month data. I'm having a 3-month data. Based on the 3-month data, I'm having 21 days prediction. So this is we call forecasting. This we call forecasting. I repeated the point. The forecasting option is available only after 2016 version. So if you have a MS Office, Office 2016 and above, otherwise you have Office 360. You have Office 360, then only you will get this forecast function. The forecast function is available on the data menu. Forecast function is available on the data menu. It is available after 2016 version only. So right now there are 2019 is there, 2020 is there, 2021 is also there. Okay. So latest version you have means you may able to do this. Any questions so far in the trend analysis? Any question in the trend analysis? Got to the point how to get the trend line, how to get the R squared, predicted equation kind of thing.
Sir, please repeat prediction.
Prediction one more time. Okay, fine.
Yes, sir.
So prediction, it's very simple. You need not to bother about anything. Just select the data. Just select the data. And then go to the data menu. Go to the data menu. The data menu forecast sheet will be there. This is available after 2016. Otherwise, Office 360. There's 2 versions only it is available. Before the version 2013, 2010, 2007, MS Office. This versions you will not get this forecast sheet. Okay, you can click here. You will get the predicted. So if you are okay, you want to alter your forecasting period, you can alter it here. For example, it predicted up to 13th April. So I want to predict up to 15th April. I want to predict up to 30th March, 30th April. So you can choose, it will be predicted. After it done, you can click create. After it done, you click create. In a new sheet, the predicted data as well as the predicted graph is available. Predicted data as well as the predicted graph will be available. This is the predicted graph and this is the predicted data. If you go down, you will get the predicted data.
Okay, sir. Thank you.
Fine. Is it clear? Shall we move to the next one? Shall we move to the next one?
Yes, sir.
Next, what we are going to talk about is descriptive analysis. How to run the descriptive analysis, okay, in the Excel. So you may study a descriptive analysis, how to calculate the mean, how to calculate the standard deviation, how to calculate the median, how to calculate the mode. These are all you may studied in a simple function. But now I am introducing one pack in your Excel, add-on pack in your